Good morning, everyone. Welcome again with the hydraulic experiment. Today, I'm going to present about the friction loss in pipe. The content for presentation today will be divided into 5 parts with an introduction, theory, formula, result and discussion, and conclusion. For the introduction, nowadays we have to know that in each of pipe will have the friction energy and the significant losses will result in a pressure decrease along the pipe, and since the pressure must be operated against the friction resistance, Dashi is the most common for the formula for calculate the energy loss in pipe flow. In the theory, we can know that it is critically important to estimate the head loss in pipe flow in order to apply the energy equation to analyze the pipe flow problems. The total head of the pipe system will compose of the head loss caused by viscous effect in straight pipe. And at the show, there are 3 types of the energy that involved in the bright flow, which is first, kinetic energy, second, the gravitational potential energy, and the third will be the energy generated by pressure. And the formula that show equal to head equal to V square over the 2G plus C plus P over rho G in where is head equal to total energy and flow velocity, P equal to pressure, Z equal to elevation, and G equal to gravity rate, and rho equal to the density water. And after that, the formula will be head loss and Reynolds number. Please remember it carefully. Then the Reynolds number we get the Reynolds number to find the friction factor. Friction factor today we will focus on 2 types, which is the Reynolds less than 2000 and Reynolds over 4000. And for the methodology, please follow the step as shown above. We will have more about 6 steps, and we have 3 types of the 3 sides of the pipe, so be careful. Next, about the result and discussion, the table 1 will be the information from calculate of velocity, flow rate, Reynolds number, friction factor, theoretical heat loss, experiment head loss, and percentage of difference. And please select after get the Reynolds number, please select the friction factor to calculate again. And the next one is the figure 1 is the relationship between experiment head loss and flow rate. For the discussion, experiment results show that the larger diameter pipe had a low head loss at the same flow rate. And this is because the energy loss within the pipe decreased with the increasing diameter. When the flow rate increased, the Reynolds number also increased as the equation that show. And next is the discussion between the friction factor and Reynolds. Friction factor and Reynolds have an inverse relationship when experimental results were compared to those present in figure. They were consistent, and where the head loss obtained in theoretical was compared to the head loss obtained in experiment value were different. And this is the discussion when we plot into the Moody diagram. We can show that D equal to 1 over 4 pipe is smooth pipe, and 1 over 4 inch pipe is in some will be the some in the smooth pipe and some will be the transition regions. And the conclusion of the experiment show that an experiment has shown the Reynolds number is inward related to the friction factor. Researchers can use it to determine the head loss produced by flow in pipe, and it was determined that when the flow rate increases in the pipe of the same diameter, head loss will be increased. And thank you for your attention.